All right, well, good morning, everyone. So we want to take a look at how to find the equation of this particular graph. The first thought I'm thinking is we need to at least recognize, well, what's its characteristic shape? We've been studying absolute value, square root, quadratic, reciprocal, and even some piecewise functions, but this one is the characteristic shape of the square root function. Square root function also looks like half of a parabola, because it's exactly half of a parabola. And when we look at these types of functions, it's sort of important to know, well, what would the parent function look like? If I had just a square root function that had not been transformed, I know the vertex of that, or the starting point would be at the origin, and our square root function, I can go to this screen here, our square root function would have started there and sort of opened to the right. Like that's what I'm trying to compare my given graph in order to come up with an equation. So right away I've noticed that there's a transformation. Right away I've noticed its opening is exactly reversed. And if you think about what's happening here, our x's have switched spots. And so when we have a translation where our x's switch spots, that's going to affect our x value in particular. So if I'm thinking, oh, the parent function is normally root x, and I want to go ahead and switch the opening of that function, I know I'm switching the x's. And so I'm going to have to make the x its opposite value. Now, initially this might cause some concern, because we know you can't take the square root of a negative value. But because we're switching our graph in order for this opening to go towards the left, it's okay to have that negative there, because the domain of x's will already have a negative value. So the x's that we're going to use to substitute into the function are already negative, and that negative makes that possible to take the square root of those particular values. So I know that the equation of my graph has to have a negative x to indicate that I'm opening towards the left. The other thing that I notice is that my vertex, or my starting point of this square root, is no longer at the origin. It's moved to the right 3 units. And so as I'm shifting things left and shifting things right, again, that's an effect in the x direction. So I want to make sure to indicate that this is going right 3 units, that I do the correct translation. Moving something to the right 3 units, well, not the whole graph, that's kind of crazy. Moving something to the right 3 units, I need to directly affect the x component. Well, how do I move that to the right 3 units? Normally, I would think about that as x minus 3. I'm moving to the right 3 units. When I think about this translation, I often think about, well, what would cause it to be a 0 in that function? Like, what would 0 in that graph? And a lot of times students kind of associate that with, well, it's sort of like solving factoring or quadratics, where you are looking for the zeros of that. Moving to the right 3 is equivalent to saying, oh, I want to subtract 3, x minus 3 from each of those particular values. And oh, look, I realize that this should be negative. All right, so I'm going to do that to make sure I get the reflection. But we have to be really careful, because we want to move the reflected graph to the right 3. So we have to also associate our translation by putting a set of parentheses here, so we know that I do want to translate 3 units to the right after I've made that reflection. You could leave it you could leave it factored out for our function, or you could distribute the negative in to make it negative x plus 3. My personal preference, I like to see it still factored, because it shows me the 2 translations. It shows me there's a definite translation across the y-axis, because all my x's have switched spots, but then there's also a horizontal translation to the right 3 units. Okay. Now, once we get that, once we know that our parabola, our half a parabola, which is a square root, is shifted to the right 3 units, we should probably also check its opening. Because there could be a lot of square roots that begin there but have different openings, and how fast that opens, or some people talk about it being compressed or stretched, would directly come from knowing what is your coefficient in front of that particular function. So if you look at a point that's not the vertex or not the starting point, you could pick maybe perhaps like 2, 1, or -1, 2, just to see what those particular points would do to our function, to see is it opening like wider or narrower than our parent function. So I'm going to use this test point 2, 1, and I'm going to substitute that into my function to see what my coefficient of a should be. So I know what my function, so f of x equals a, the square root of -x plus 3. I'm not really sure why I just rewrote that, but that's okay. We can move it right there. So I'm going to substitute 1 for the y and 2 for the x. So 1 for the y and 2 for the x. I guess we do this. Oh. Trying to get fancy on my color. And solve. So let's see, -2 plus 3 would give me 1. So I have 1 equals a, the square root of 1, which is 1. And so in this case, there is no horizontal vertical compression, it's just a is equal to 1. So my lead coefficient would just still be a 1. So my final answer then, in terms of what is the equation of that function, would be f of x equals the square root of -x plus 3, or an equivalent would be f of x equals the square root of the opposite of x minus 3. Either one would be fine. Make sure you do call it a function, f of x, y equals, and make sure that, I always tell the square root should cover the whole expression. This, again, as just a recap, this negative gives you the x's switching directions, and this gives you a translation to the right.